Hey everybody, Dr. A here, and in this video we're going to be exploring an example of shear strain. So let's get started. Here we're being told that a wall is subject to a lateral load that causes it to deform. And then we're being asked, what is the shear strain at point A relative to the XY axes? So let's take a look at the figure we have here. So in this figure, we see that we have a wall, and this is defined by this black line figure here. And each corner of the wall is at 90 degrees initially, okay? And the wall is fixed at the base, and point A represents the origin where we have a x-axis, an x-axis coming out to the right, and a y-axis coming upwards. Now, we have this lateral load that we're calling V that's applied to the top of the wall that's causing this wall to deform. The new angle that the wall now has is 87.5 degrees at point A, whereas its original angle would have been 90 degrees. So what is the shear strain at point A? So to get started, we're going to say solution, and we're going to recall that shear strain we call gamma is going to be equal to an original angle minus the new angle between the two axes that we're interested in, okay? So the original angle is 90 degrees. The new angle is 87.5 degrees. Now, we often express shear strain in radians. So what I'm going to do is instead of saying 90 degrees, I'm going to say pi over 2 radians. That's the original angle. And then the new angle is going to be the 87.5 degrees, but I need to convert that to radians. So I'm going to say 87.5 degrees, and I'm going to multiply that by pi over 180. That's our conversion from degrees to radians. We say pi radians over 180 degrees. And we punch this difference through. So let's do this together. First, I'm going to convert the 87.5 times pi over 180. And then I'm going to take pi over 2, and I'm going to say pi over 2 minus that angle converted to radians. And let's see what we get. So we end up with 0.0436 radians, okay? Now, that became a positive number because we started with a larger value here, pi, which is 90 degrees, and we subtracted from that the smaller angle, here, the 87.5 degrees converted to radians, and we got a positive value, a positive strain. So not only would this be a positive strain, but we would see kind of a compressive sense in the vicinity of point A here. So that concludes this very simple example of shear strain. If you found this helpful, please hit like and subscribe, and be on the lookout for content similar to this. Thanks for watching.